All right, so here's an example. Say that I wanted to convert a polar point to a rectangular point. Okay, so I have 7 comma pi over 3, but I want to know how much over and how much up that is.
Okay, we can do that.
I think we can manage this. What's your first thing first for these? Yeah, I would probably advise to graph it. Is that necessary?
No.
No, because I have formulas to convert, right? Do you want to memorize all the formulas to convert?
Probably. I mean,
Well, there's the ones we did before. So there's x is, y is, r is, and theta is.
if you just look at the picture, though, it's only 4.
Yeah, so I would contend, or I would propose that those are unnecessary, that you can get them off the picture. If you want to memorize them, go for it. I'm going to get them off the picture, so for me, graphing this thing is going to be crucial. So how do I graph this thing? Here's an x and a y, right? That's the land I want to go to. And I'm living right now in r and theta land, right? So how do I draw an r and theta thing in xy land? Okay, so I need to find pi over 3 as an angle. So that's maybe like this. Right? There's my pi over 3. And then I need to go out 7 units. So here's my point, right? This is 7 long. And what the heck am I looking for? I'm looking for x and y, right? So how do x and y relate to this business?
X is R.
Yeah, that's too much. How about remember that x and y are over and up, right? So I want to know, here's my point, right? That's the point I want to figure out about. So I want to know how far over is that thing? And how far up is it? You guys see that boils down to me trying to solve this blue triangle?
You need the tangent.
So, yeah, so this is going to be the x, right? This is going to be the y. So, what did you suggest?
Rise over run.
So close. Yeah, so I think I want sines and cosines, right? Because I know the angle and the hypotenuse. And I want to know the opposite side and the adjacent side. It's a good idea to note, right, that there's a rise over run thing I could do here. You guys see that? There is a way to do it that way. It'll be much more tangled. I would really recommend for noting that y here, right? When you see y, you're thinking opposite side, right? So you should be thinking, all right, there's a sine of what angle? Pi over 3. And that's going to equal what? Y over 7, right? That's one thought process. The other one is you could note this is a standard triangle, right? You guys see that? So you could calculate this, or you could note that this is a 30, 60, 90 triangle, right? So I'm thinking 7's like 2, x is like 1, and y is like square root of 3. So then I need to figure out some kind of inflation factor. You guys see that? Okay, either way. So whatever you end up with, what are you going to get on a y for this? Think you're going to get 7, right? Times sine of 60 is root 3 over 2. Cool. And x, however you get x, you're going to get what? 7 times a cosine, right, of 60, which is 1/2. Please note the thing I'm doing is I'm thinking that the inflation factor was 7 over 2. Okay, see that? So either way. So what are my coordinates for my point? Like this guy, right? Should be an answer. X comma y. So what was your x? 7 over 2. And your y? 7 square roots of 3 over 2. You guys cool with that?
Can you do the X again? Like talk through?
Yeah, so talking through the x, I look at x and I think, all right, x here, that's sitting in the adjacent spot, right? Okay, so I'm going to look at that and I'm going to think, all right, the cosine of pi over 3 is the adjacent side, x, over the hypotenuse is 7. Then I'm going to multiply both sides by 7. So I'm going to get x is 7 times, and then the cosine of 60 degrees is 1/2 from my triangle or wherever. And so I get 7 over 2. Cool? Questions, things? Okay. So this way, from polar to rectangular, is pretty easy usually. Other way is a slightly different story.